Okay, today we are going to work on 1.1, which is linear and rational equations. So our objective for 1.1 is to be able to solve linear equations in one variable algebraically and solve a rational equation. So here is the step-by-step guide for solving a linear equation. Linear equations only have one variable, and we solve for that variable. In this case, x is the variable. And you can read through these steps, but I'm going to model them for you on the next few slides. So on this first example, 2x plus 7 equals 19. We're going to solve for x. We need to isolate x, so I'm going to subtract 7 from both sides to begin with. And on the left-hand side, that will cancel, and we will get 2x equals 12. Then we'll divide both sides by 2 to get x by itself, and we get x is equal to 6. So that's our solution for the first one. For this second one here, our variable is a, so we're going to solve for a. I'm going to add 2 to both sides. And once I do that, I see that I just have this negative 7 times a on the left-hand side. So I'm going to divide by negative 7 on both sides to give me a is negative 2. So here we have 3x plus 4 is equal to 5x minus 10. I'm going to get my x's on one side and my whole numbers on the other side. I personally like to try to keep x positive, so I'm just going to subtract 3x from both sides. So on the left-hand side, I get 4 equals 2x minus 10. Then I'll add 10 to both sides to get 14 equals 2x. Divide by 2 to get 7 equals x, or you can write it as x equals 7. Either is correct. On the right-hand side, I would simplify before I tried to solve. So I would distribute this 4 to both terms inside of the parentheses. So I get 4k minus 12 minus k equals k minus 6. And then I could combine like terms. Here I have a 4k minus k. So 4k minus k would give me 3k minus 12 equals k minus 6. Now I'm in the position to move my k's to one side and my whole numbers to the other side. So I would subtract k from both sides, giving me 2k minus 12 equals negative 6. Then I would add 12 to both sides to give me 2k equals 6. And then I would divide both sides by 2. And so my final answer here would be k is equal to 3. You can check by substituting back into the problem and making sure that both sides are equal to the same thing. So let's do this one. I'm going to add 4x to both sides. And I get 8x plus 3 equals 27. Then I'm going to subtract 3 from both sides. And then divide by 8. So I get x equals 3 as my final solution. Here, I'm going to go ahead and distribute to all of the terms. So on the left-hand side, I get 2x minus 4 equals. On the right-hand side, I get negative 3x minus 12. I'm going to add 3x to both sides. So I get 5x minus 4 equals negative 12. I can add 4 to both sides to give me 5x equals negative 8. And then divide by 5 on both sides to give me x equals negative 8/5 as my final solution. So for this problem, the first thing that we would need to do is find a common denominator. So we have 4, 14, and 7. We can clearly see that the least common denominator here is 28. We find that by multiplying out until we find a number that all three numbers have in common. So if I count by 4s, that gives me 4, 8, 12, 16, 20, 24, and 28. If I count by 7s, I get 7, 14, 21, and 28. And if I count by 14s, I get 14 and 28. So that's how I went about finding that least common denominator, because it's the first multiple they all have in common. So once I have my least common denominator, the next thing I'm going to do is multiply both sides by that least common denominator. So I'm going to multiply this side by 28 and multiply this side by 28. What's happening when I do that is on this side, I'm getting 28 times x minus 3 over 4. And here I'm getting 5 over 14 times 28 over 1 minus 28 times x plus 5 over 7. I usually skip this step when I'm doing it and just go ahead and reduce, but I wanted to show you how to reduce here. So 28 divided by 4 gives me a 7. So I'm left with 7 times x minus 3 equals, here 14 and 28 leaves me a 2 right here. So I'm left with 5 times 2. And then 28 and 7 here, it leaves me a 4 here. So I'm left with 4 times x plus 5. So now I can do my multiplication. So I get 7x minus 21 equals 10. Make sure you distribute this negative with the 4 on both terms here. So I get negative 4x minus 20. So on the right-hand side, I can combine like terms. And then I can add 4x to both sides. I'm going to continue right here because I'm running out of room. So 7x plus 4x will give me 11x minus 21 is equal to negative 10. So then I can add 21 to both sides. I get 11x is equal to positive 11. And then I can divide both sides by 11 to give me x equals 1 as my solution. So this one, I'm not going to do it step by step like I did the last one, So if you need to go back and fill in the steps that I'm going to be skipping as we go, please make sure that you do that. So here, my least common denominator is going to be 8. So I'm going to multiply both sides by 8. When I multiply by 8 here, in this first term, the 8's will cancel, and I'll be left with 5m. In the second term, I'm going to have 8 times negative 10. So I'm going to get negative 80 equals. Here, the 4 and the 8 will reduce to 3 times 2. So I'll get 3 times 2 to give me 6m. And here, half of 8 is 4, so I get plus 4m. Then I'm going to combine like terms, so I get 5m minus 80 equals 10m. I'm going to subtract 5m from both sides. That gives me negative 80 equals 5m. So then I can divide by 5 on both sides. And my final answer would be m is equal to negative 16. This one, my least common denominator, is 12. I'm going to multiply both sides by 12. So when I do that, 12 and 3 will cancel to leave me with 4 times 5a. And then minus 12 times 6 here. Here, 12 and 4 will cancel to leave me 3 times 3a. Plus half of 12 is 6, so I get 6a. So now I'm going to do my multiplication. So I get 28 minus 72 equals 9a plus 6a. I can combine like terms to give me 15a. I'm going to subtract 20a from both sides to give me negative 72 is equal to negative 5a. And then I can divide by negative 5. So when I do that, my final answer is a is equal to 72 over 5. So here, these are called rational functions. And so we're going to work with these rational functions. The first thing we have to realize when we're solving rational functions is that division by 0 is undefined. That's a rule. So we know that division by 0 is undefined. So with that being said, we cannot get 0 in a denominator of a fraction. So when we do that, we want to make sure that we state clearly what x cannot be. So in this case, we could take the denominator and set it equal to 0 to find out what they cannot be. So any denominator that has a variable in it, I'm going to set to 0 and then solve for that variable. So we find that x cannot equal 0 based off of the solutions we got for our denominators here. Same thing on this one, x plus 1 cannot equal 0, and x minus 2 also should not be equal to 0. So x equals negative 1 and x equals 2 cannot be solutions. So we see x cannot equal negative 1 and x cannot equal 2. So you see that the first step in solving rational equations is checking for that 0 that we can't have on the denominator, finding what solutions we're not allowed to have to make sure we don't get division by 0. And then we solve. So here, the first thing I'm going to do is that check our zeros here. So since I have x and 2x, both of those equal to 0. Anytime you see a multiple of x equal to 0, it's just going to be that x cannot equal 0. Because if I divide any 0 by any number, I'm still going to get 0 there. So our only value we can't have is x equal to 0. So we know that x cannot be equal to 0. So with that being said, now we can find a least common denominator and solve this very similarly to what we were working on before. So our least common denominator here, if we have a 2x, a 5, and an x, our least common denominator is going to be 10x. So I'm going to multiply both sides by 10x. So here, we'll see that the x's will cancel, and we'll be left with 10 times 1. On this one, let's just say we distribute this to both so that you can see it more clearly. We get 10x here when we distribute. So this 5 and 10 will reduce to give me a 2, so I'll have 1 times 2x. Minus this 2 and this 10 will reduce to give me a 5, so I'll have 3 times, and then the x's will go away, 3 times 5. So I get 10 is equal to 2x minus 15. Oh, sorry, plus. I didn't write it as a plus, plus 15. So now from this step, we can solve for x just like we would any other problem. So I'm going to subtract 15 from both sides to give me negative 5 is equal to 2x. Divide by 2 to give me x is equal to negative 5/2. We check to make sure negative 5/2 is not a restricted value. It's not, so our solution is x equals negative 5/2. Solution set notation, if we wanted to write this as a solution set, we would write it as the set that contains x such that x is equal to negative 5/2. That's solution set notation. So the same thing here. We know that x minus 3 equal to 0. If we solve for that, we get x equals 3. So we can't have x equal to 3 as one of our solutions. So we're going to check that at the end to make sure our solution is not 3. So my least common denominator here is going to be x plus 3, or I'm sorry, x minus 3. So I'm going to multiply both sides by x minus 3. On this first term, these will cancel. I'll be left with x equals. On the second term, they'll cancel. Here, 3. Here, this is a 1, so there's nothing to cancel with it. So I'm going to have 9 times x minus 3 here. So then I can distribute. After that, I can combine like terms. I'm going to move my 9x by subtracting. So I get negative 8x equals negative 24. So then I can divide by negative 8 here. So I get x is equal to positive 3. Now we just said that that's our restricted value. So since our restricted value is the solution here, there is no solution. In solution set theory, in set notation, you can either just have empty curly braces to demonstrate no solution, or you can have 0 with a line through it to demonstrate no solution. All right. So for this one, same thing. X plus 2 times x minus 1 is clearly going to be our LCD here because it is what will combine all of these. So I know that x plus 2 cannot equal 0 and x minus 1 cannot equal 0. So x cannot be negative 2 and x cannot be positive 1. So we don't want x to be equal to negative 2 or 1. If we get either one of those solutions, then we have a problem. So I'm going to multiply both sides. I'm just going to write it as one multiplication this time. X plus 2 times x minus 1 because I'm multiplying everything by that. So on this first term, the x minus 1 is going to cancel, and I'll be left with 3 times x plus 2. On the second term here, the x plus 2's will cancel, and I'll be left with 1 times x minus 1. And then on this last term, both terms will cancel, so I'll be left with 9. So from here, I'm going to go ahead and distribute. I get 3x plus 6 equal to x minus 1 plus 9. So I'm going to combine like terms. So I get x plus 8. So then I'm going to subtract x from both sides to give me 2x plus 6 equals 8. Subtract 6 from both sides. I'm going to continue right here to give me 2x equals 2. And then divide both sides by 2 to give me x equals 1. Well, we said x could not equal 1 right here. So again, our answer is no solution. And I often write it with a 0 with a line through it. So again, we see it, we have multiples of x, so we know that x cannot equal 0. So 0 is our restricted value here. So we're going to multiply both sides by the least common denominator here. This time we're thinking 3, 4, and 6. That gives us a 12, and then we have an x, so we need to take that into consideration. So we're multiplying every single one of these values by 12x. So I'm going to write that out just in case you've kind of been losing that idea there, that's what I'm doing when I'm doing this cancelization. So I'm doing 12x times 1/3 minus 12x times 7 over 4x equals 12x times 1/4 minus 12x times 1 over 6x. So in that step, I'm distributing that 12x to every single thing. We know that 12x can just be written over 1, right? Because anything divided by 1 is itself. So now we can do some canceling. Here, the 3 and the 12 will cancel, and we'll be left with 4x as this term. Here, the 4x and the 12x will reduce to 3 because the x's will cancel, and 12 divided by 4 is 3. Here, the 4 and the 12 can reduce, and we're left with 3x. And here, the 6x and 12x reduce to a 2 because the x's cancel, and 12 divided by 6 is 2. So we get 4x minus 3 times 7 equals 3x minus 2. So 4x minus 21 equals 3x minus 2. And now we can solve. So minus 3x from both sides to give us x minus 21 equals negative 2. I'm going to continue right here. So I'm going to add 21 to both sides to give me x is equal to 19. So we check x can be 19 because the only restriction is the 0 here. So if I write it in solution set, that would be the set that contains x such that x is equal to 19. So we have one more. Here, again, we don't want the denominator to equal 0. So in this case, x cannot be -4. So our restricted value is -4 here. So I'm going to multiply everything by x plus 4. So on this first term, it cancels, and I'm left with 3. On the second term, I get -7 times x plus 4 because there's nothing for it to cancel with. And then here it cancels as well, and I get -4. So then I'm going to distribute. Make sure you carry that negative when you distribute. And then combine like terms. I'm going to add 25 to both sides. So I get -7x equals 21. And then divide by 7, or -7 from both sides. So my final answer gives me x equals -3. -3 is not a restriction. So our solution set is x such that x is equal to -3. And so that concludes 2.1. So next time we'll work on 1.2.